I'm Bryce. I run cross country and I want to study computer science in college.
I'm Albert. I want to study mechanical or electrical engineering at Purdue or Rose-Hulman.
I'm Alex. I play volleyball. I want to be an engineer on the IndyCar team.
I'm Nick. I want to study electrical engineering at Purdue.
Okay, so here's our problem statement. Fork Farms currently provides millions of meals to thousands of people all across the United States. To produce a good quality of food, the pH needs to be kept in between 5.5 and 6.5 pH. There also needs to be a sufficient amount of nutrients put into the system. This all needs to be automated so that the time for maintenance is as low as possible. So here's a graph with the market for hydroponic farms. So right now it is at about $8 billion, but by 2032 that is going to increase to $35 billion. So the market is going to expand. So we also made some rough sketches and threw some ideas at each other to try to figure out what our main design was going to look like.
With each of the members all making their own design, each of them coming from different ideas and thoughts of what we can do with all the farms, with them all including the 10 ideas of the farms, making sure all the pH levels stay the same, with each of them all, like I said, having the same rough concept with how to design the pH level to stay the same with all the Fork Farms stuff, as well as the Anderson Hauser equipment.
Okay, so we had some similar solutions that we looked at before we created our final design to try to get some ideas on what to make it. So the nutroponic growth tower was unable to automate pH, and it was also unable to manage nutrients. This would all have to be done manually. The next product was the farm shelf hydroponic indoor garden. And there was no way to be able to connect the farms to increase the amount of produce that you could make. And it also needed to be manually cleaned. And the final product is the container farm, which the plants rotate inside of it, and that rotation speed was not optimized for plant growth. And it also used too much power.
This is our final conceptual design. Our design mainly incorporated four Anderson Hauser products, that being the CM444, which is a 4-channel transmitter, which just connects all the different parts of the farm together and transmits it onto like a PLC that displays all the information needed to like monitor the farm correctly. And the second product is the ProLine ProMag electromagnetic flow meter, which just diagnoses the amount of water flow that is inside our farms. And the third product is the MemoSense CPS 11E, which is our pH sensor that is used on each of the farms to regulate the amount of pH to maintain that it's between that desired 5.5 to 6.5 range. And the last product is a CM444R, which is pretty much the same as the CM444, but it can just do a little bit more. All right. Here's our full system assembly. We used Leo utility transfer pumps all around our design to connect all the 10 flex farms together. And then the pumps also lead outside, exiting the farms into the refiltration system and back into the big water tank in the center. In the refiltration system, there's an agitator which stores all the necessary ingredients, like all the nutrients, the pH ups, pH downs as needed to like modify our pH to get it at that exact desirable pH range.
Alright, so here's the build modifications we added to the initial design. We added flow meters to measure the amount of water in each tank, and then flow switches to control the water going in and out of each tank. And then we added automated nutrient dispensers, and then a PLC, programmable logical computer, to control the measurements from the sensors.
And with this, we go to our final CAD design. From our sketches, we come with all the blue pieces on there are all Anderson Hauser or Rockwell automation parts, with the two extra water tanks on the side for nutrients and helping out with the pH level sustainability, making sure it's all stay the same. With the two main water tanks out there with all the piping coming in and out, and making sure all the water tanks stay the same. Top aerial view of that where you can see all the different pH sensors, making sure, like I said before, that they all stay the same level and it all stays within a good amount. Here are the parts from CAD, that is the actual prints, so you can see the actual professional parts of it. And then for our testing, we follow on, like I said, with how the pH sensors keep it all the same. It stays all the same levels, make sure it runs with the PLCs, PLC's helping make sure it's all automated, and so no one has to do anything for itself.
Then this is our expert list. We received feedback from our first presentation from these Indris employees.
So here's our parts list. This encompasses every single part that we use on this project. It has all of our Indris Hauser parts and Rockwell automation. And our final price without the Flex Farms is $57,000, and the added cost of the Flex Farms brings it to $107,000.
Thank you all for listening. Is there any questions?